Hello, my name is Jacob Little. I'm a computer engineering student at North Carolina State University, and this is my demo for Project 10, ECE 306, Embedded Systems. All right, so we'll begin by turning the vehicle on, and we start with the loading screen to show the IP address. It takes a little while for the IoT module, which is the Wi-Fi chip, to start up and grab the IP address, but once we have it, it will display on the screen. There we are. Give it a little bit, and eventually it will say waiting for input. All right. Now we can begin to navigate. I'll send a forward command. And there we go. Start moving forward. You see we're going 0 to 1, and you'll see every time that I move in any direction of any kind, the display updates to show what kind of movement I'm doing. So now we're going to start making our way to the 1 square. So I chose computer engineering because I've always enjoyed computers, video games, and I've always loved owning the most powerful hardware I can and really taking advantage of it and using it in cool ways. And it's that type of, creative drive that people can use computers for that really intrigues me and makes me want to be a part of making computers as best they can be. You've arrived at 1, and now we are going to go from 1 to 2. Back up, turn around this way, and keep navigating. I chose NC State mostly because of its really good reputation as not only just an excellent university, but also as an engineering university. And so far I think it really has held up to that name. I think my education so far at the university has been pretty excellent, aside from a few bumps in the road here and there, but what can you do? We've arrived at 2. Now we're at 2. Now we go from 2 to 3. Back up. Let's make our way to 3. During having to do everything from home, especially for this class, has been pretty difficult. But I think NC State in general has done a very good job, and Professor Carlson, who teaches this class, has done an excellent job of trying to make things work in, a non-optimal learning situation. And it's been rough, the semester's been shorter than normal. We don't have the in-person time that we're used to. And overall, it's just been a very stressful semester. But I do feel like I have learned a lot, maybe not as much as I could have. In a physical semester, we have arrived at 3. I'll turn around so you can actually see that. New. All right. 3 to 4. But I really have enjoyed it here. And I don't know when we'll be able to go back in person, but I am really looking forward to it, especially being able to meet the students again, see the students again that I have become friends with, and get to see the professors that I've enjoyed learning from. I'm about to approach 4. Let's see. We've arrived at 4. 45. We're going to take the long way around. I don't have a whole lot of room for this. Typically, we would be doing this on campus where there would be a set track that everyone uses. Unfortunately, due to the scenario, we've had to set up our own tracks. And there are certain guidelines that we have to follow. Like each number has to be at least 20 feet apart. No number can have a direct line going straight to it, so you can't just drive straight from one number to the other. But I do believe I have followed those directions as solidly as I possibly can. It's a little bit difficult to measure distance in this kitchen, and obviously I'm having to follow very similar paths for a lot of this. But some people are doing these in dorm rooms, and they have even less room to work with. All right, stopped at 5. It's gonna be a little difficult, but I'll try to show my best. All right. Arrived at 5. 5 to 6. Oy. go this way this time. As you can see, I have made my car look, decorated my car a little bit, giving it almost like a spooky theme. When you work on something like this for the entire semester, you really start to kind of have almost like a child complex, or parental complex, I should say, over the device you create. And you want to dress it up, you want to make it look nice. You want people to be proud of what you made. Alright, here soon. We have now arrived at 6. Time to go to 7. Yeah, but we've been working on this project this entire semester. There have been 10 parts to it. This is the 10th part. Each part has progressively gotten our own embedded system to become more and more complex. And we've learned a lot throughout the whole process. And it's really cool what we've actually been able to do. And while this might not seem incredibly impressive to anyone who's used something like Mindstorms or an Arduino, what's important to realize is that we're working very close to the hardware. We're using a very simple coding language, a very simple processor. All right, and I'll cut that discussion off right now because we're about to start something important. Let's go ahead and arrive on 7. Now let's make our way from 7 to 8. So 7 to 8 has to be, it's a little bit different than normal. You'll notice it's much shorter than the other paths, and it has a straight path to it. That's because for this one I have to make a continuous movement from 7 to 8 with very minimal readjustment. I can't reverse, for instance. I can turn left to right a little bit, but once I get within 2 feet of 8, nothing else. All right. All right. Now it's time to trigger my command to follow the black line. Now normally, I should probably also show, we have indeed reached 8. Now normally, I would put down my controller, which is my phone right now, so that I could show that I'm not controlling the vehicle at all. Unfortunately, because I'm also recording this, there's not a whole lot I can do about that. You're gonna have to take my word for it, but I think it will prove for itself that it's clearly not being driven by me. All right. Let's get a nice look at the display as I commence black line. The vehicle will start moving. All right, we can see we have now intercepted the black line. We'll move forward a little bit, and we'll start detecting the line and following it. You can see that we are now traveling, and we have reached the junction. We'll begin to follow around the circle. And this part's going to take a little while. I did design this to try and be slower than usual, but that's mostly just because I want it to be repeatable. I do get bonus points if I get to do this all in one go, which at the moment it seems like it will be able to do it all in one go, so that's good. We'll keep going around. It is a little slow. A lot of that is because I'm using a metal caster on the bottom, and the rubber of the rubbery substance of the electrical tape sometimes slows it down quite a bit. We're getting there. We are about to be at the second rotation. This is around the point where I would pick up the phone so that I could, show my exit command. Obviously, I'm already holding the phone because of having to record it. And now I will send my command to exit. I'll try to get this on screen as I'm going. And there we are. We have stopped. Done in 552 seconds. That's I don't know. That's about 10 minutes, actually a little less, closer to 9 minutes. And I think that's about it. So I would like to say thank you to Professor Carlson and the TAs of this class. You guys have taught me very well, and I think that you guys have really done a fantastic job given the circumstances. I really appreciate it. This has been an amazing class. I'm kind of glad that it's almost over. Admittedly, it has been very stressful, but really, genuinely, I appreciate everything that you guys have done for me. And thank you so much.